Hello all. This is the first video in the database design series. Um, a common advice that you see on the internet is that you need to learn database normalization if you want to learn how to design databases. You see that all the time. Confused beginners asking for advice on database design. And you see a lot of responses that basically boil down to you need to learn normalization, you need to apply normalization, you need to normalize your database, your data is not normalized, and so on and so on. Unfortunately, it seems that this is not a very actionable advice, especially for beginners. And in this series of videos, I'm going to talk about why this is the case and how we can give a better actionable advice. So if you think that normalization is somehow good, and this is the impression that you get from all the advice, then the question is denormalization bad? And is it maybe even wrong? But this is actually not what you see in the real world databases. The databases that you can see in different companies and software systems and so on and so on. And I'd like to talk about a common use case of denormalization and how and why it's done. So let's take a look at the simple use case. We have restaurants, we have cities, and we have orders that people make at those restaurants. So let's design three very simple tables. The first table is cities, the second table is restaurants, and the third one is going to be orders, right? So the first table on the left, we have two columns: ID, that's numbers from 1 to 3 and so on, and the name of the city: New York, Amsterdam, and so on. On the right, you see the second table, restaurants. And here we have three columns. One is the restaurant ID. That's like 10, 15, 20, and so on. Then you have the name of the restaurant and a column that keeps the city ID where this restaurant is located, right? So we can see that, for example, the clause has ID 20 and it's located in city ID 2. And looking at the table, at the left table, we see that it's Amsterdam. That's all very simple, nothing surprising. We can see that those two tables are in third normal form. How do we see that? Because we can change any of the attribute values for this specific ID. We're going to talk about that in more detail in follow-up video, how to see and confirm that the table is in third normal form or not. Another table is the table of orders. We have 4 columns. So we have an ID of the order, 100, 101, and so on and so on. We have a reference to restaurant ID, 10, 20, 15, 25, and so on. And we have 2 columns, time when the order was placed and the time when the order was marked as delivered. This table is also in third normal form. The primary key is ID. Restaurant ID is refers to the table of restaurants, and so on and so on. suppose that we need to run a very important business query. We want to find a number of orders made at each day for a specific city, for all the restaurants in the specific cities. We have a pretty simple SQL query with one join. So we select from a table of orders, but we need to filter this query by city ID, which is stored in a different table. So we join orders with a table of restaurants. We filter by city ID equals 1, that is for New York, and we select the date for when each of the order was placed, and we want to know the number of orders, and we also group by date of when the order was placed. So again, this is a very simple aggregate query. Suppose that we really want this query to run as fast as possible, and maybe one of the ways to do that is that we want to get rid of the join. This is a tricky part. I'm going to talk about disclaimers in the following slide. So what we can do is that we can make a copy of city ID directly in the table of orders. So here you see in the third column, we've inserted another column, and it contains a copy of the city ID. So basically for restaurant 20, we know that it's in Amsterdam, city number 2, and we make a copy, and we do that for all other restaurants. And when we insert the row in the table of orders, we carefully copy the city ID from the restaurant. So this column is not in the third normal form. We're going to talk about why we are so sure in the follow-up video. But now we can change the query and remove the join. So now we can directly filter by where orders.city ID equals 1. The rest of the query is the same, grouping by date part of the time placed and so on. So a lot of disclaimers apply here. This is not an endorsement of this approach. It's not that I recommend you to do that. We're going to talk about the cons of this approach in a follow-up video. This approach may not even be necessary. It's not guaranteed that your query version 2 is going to be faster than the query version 1. Also, this example is pretty trivial, and it's possible that this is not like the best example of how to show this performance improvement. But we are not talking about performance improvement. We want to show what happens with the normalization and denormalization stuff, right? Of course, adding the copy of data is not free, and we're going to talk about how it's not free. What cost are you going to pay for if you want to go that way? if you want to go that way. But having said all of that, we can also say that this approach is a common, very common practice, and there is absolutely nothing wrong with that. You will see a lot of tables in the real world databases that do exactly that. They store the data in one table, and then they make a copy in a different table, following exactly this pattern. So we have a bit of a paradox here. We deliberately introduced denormalization in our database schema. And if we listen to advice on the internet, we know that there is something wrong with our denormalized approach. But at the same time, we improved the performance of an important query. And we actually, a lot of people won't see any problem with this database, with this database design. Why? So when we'll discuss that in more detail, we can even see that this is a pretty well-designed denormalization, right? So maybe actually the real advice should be you must learn denormalization. Moreover, in this particular example, is it even a real denormalization? Because initially we had a perfectly designed third normal form database. And then we've added additional column that is denormalized. But if we forget about this column, the new column, if we ignore it, our main database is still a perfectly designed third normal form database. So the question is if it's actually denormalization. And to answer that question, in the second video, we are going to look at the actually denormalized design. We will try and see how would it look if you actually violate the normal, the third normal form. And we'll see that it's a bit different than what we did here. So other follow-up videos in this series are going to be how to confirm third normal form that our table design is in third normal form or not. We can do that without theory. We will see why this normalize your tables is not a very actionable advice. If somebody gives you this advice, it's hard to follow for you if you're starting, but actually even if not, because like people do something else, it's not like a normalization process. We're going to talk about that. Also, going back to practicalities, we can discuss the costs of making the copy of this data, like what do we need to do and what we need to think about if we want to make our queries faster, attempt to make our queries faster, basically. So why I am talking about all of that? So I wrote a book, database design book, that attempts to show how to actually design the database, starting from business requirements, going through the logical design process, and then choosing table design strategy and implementing this table design strategy. So thank you for listening. See you in the next video.